Hi everyone, good morning. Dear children, in the previous class we learnt four properties of inverse trigonometric functions, that is sine of sine inverse x is equal to x, cos of cos inverse of x is equals to x, so on. Then second one, that is sine inverse of sin x is equal to x. Similarly, cos inverse of cos x is equals to x. And the third property, so sine inverse of x is equal to cosecant inverse of 1 by x. Cos inverse of x is equals to secant inverse of 1 by x. And the fourth property, sine inverse of minus x is equal to minus sine inverse of x. Tan inverse of minus x is equals to minus tan inverse of x. We have cosecant inverse of minus x is equals to minus cosecant inverse of x. Today in this class we will see the remaining properties of inverse trigonometric functions. So in that we have a fourth one, that is cos inverse of minus x is equal to pi minus cos inverse of x. Cot inverse of minus x is equal to pi minus cot inverse of x. Then secant inverse of minus x is equals to pi minus secant inverse of x. So we'll prove one by one. See, earlier we had sin inverse of minus x is equal to minus sin inverse of x. Tan inverse of minus x is equals to minus tan inverse x. And then cosecant inverse of minus x is equals to minus cosecant inverse x. So now we have cos inverse of minus x is equals to pi minus cos inverse of x. We'll prove one by one. First one we have, that is cos inverse of minus x is equals to pi minus cos inverse of x. Here go for substitution, that is put cos inverse of minus x is equals to theta. Therefore minus x is equals to, bring this term to RHS, therefore it becomes cos theta. Again x is equals to multiply by minus on both side, so therefore we have minus into minus plus x is equals to minus cos theta, So again x is equals to, here remember you can't write the minus cos theta as cos of minus theta. Here minus absorbs, it becomes plus only. So therefore we have to convert this to what? Cos itself only, but remove the sign. Therefore I'll write this like this, that is so minus becomes cos of pi minus theta, again x is equal to cos of pi minus theta. We know that, so already explained you that, so 90 plus or minus theta, or 270 plus or minus theta. Here the ratio changes to its co-ratio, that is sin to cos, cos to sin, tan to cot, cot to tan. So whereas when you use it is 180 plus or minus theta or 360 plus or minus theta, the ratio doesn't change, that is the ratio remains same, sin becomes sin, tan becomes tan, cos becomes cos itself only. Okay, so therefore so pi, then once again you have to determine the sign of this depending upon which the particular value falls, in which quadrant the particular value falls. Okay, so here this, we'll consider this So we know that cos of pi minus it becomes what? Cos theta, right? Again, so pi minus 180 minus means it comes in which quadrant? Second quadrant. Second quadrant, we know that sine and cosec only positive, remaining are negative. Therefore, cos of pi minus it is equal to minus cos theta. Minus cos theta. Again, that is x is equal. Now bring this cos to LHS. Therefore, cos inverse of x is equals to pi minus theta. Pi minus theta. But what is the value of theta? We have here cos inverse of minus x. Therefore, that is cos inverse of x is equals to pi minus cos inverse of minus x. Cos inverse of minus x. Interchange the terms. So therefore, that is cos inverse of minus x is equal to pi minus cos inverse of x. Okay, hence again, so this is cos inverse of minus x is equal to pi minus cos inverse of x. Again, so cos inverse of minus x is equal to pi minus cos inverse of x. To prove this, put cos inverse of minus x is equals to theta. Therefore, minus x is equal to cos theta. Therefore, x is equals to minus cos theta. X is equal to, this can be written as cos of pi minus theta. Again, therefore, bring the cos to LHS. Cos inverse of x is equal to pi minus theta. Again, so resubstitute the value of theta. That is cos inverse of x is equal to pi minus cos inverse of minus x. Interchange the terms. Therefore, cos inverse of minus x is equal to pi minus cos inverse x. Similarly, next one we have cot inverse. Okay, we have cot inverse. So that is cot inverse of minus x is equal to pi minus cot inverse of x. To prove this, again put that is cot inverse of minus x. Cot inverse of minus x is equal to theta. Therefore, what is minus x? Minus x is equals to cot theta. Again, multiply by minus. Therefore, minus into minus plus. X is equal to minus cot theta. Minus cot theta. Again, x is equals to, I'll write like this. That is cot of pi minus theta. Cot of pi minus theta. You know that. So pi andre value or ratio remains same. Okay, it becomes cot theta. So pi minus theta means it comes in second quadrant. So in second quadrant, cot is negative. Therefore, minus cot theta. Again, bring the cot to LHS. Therefore, that is cot inverse of x is equals to pi minus theta. Again, that is cot inverse of minus cot inverse of x is equals to pi minus theta value. We have here, that is cot inverse of minus x. Cot inverse of minus x. Bring this term LHS and this to RHS. Therefore, that is cot inverse of minus x is equals to pi minus cot inverse of x. Cot inverse of x. Okay. So next we have secant inverse of minus x is equal to pi minus secant inverse of x. Students, will you try this? Same, use the same method. Okay, that is put, we have sine inverse, secant inverse of minus x is equals to theta. Therefore, minus x is equals to, we have secant theta. So again, so multiply by minus, we have that is x is equals to minus secant theta. Minus secant theta. Again, x is equals to, so that is secant of pi minus theta. Secant of pi minus theta. Again, bring this side. Okay, therefore it becomes secant inverse of x is equal to pi minus theta. Substitute the value of theta and interchange the terms. Again, you should remember this 3 plus 3, 4 properties. Then which are the first 3? That is sine inverse of minus x, tan inverse of minus x, and cosecant inverse of minus x. Here for sine inverse of minus x, minus comes outside. For tan also, as well as for cosecant. Okay, whereas for these three functions, that is cos, cot, then secant, cos inverse of minus x is equals to pi minus cos inverse of x. Then second one we have cot inverse of minus x is equals to pi minus cot inverse of x. Then we have secant inverse of minus x is equals to pi minus secant inverse of x. For first three, that is sine, tan, cosecant, minus comes outside, whereas for cos, cot, secant, pi minus that respective inverse functions, right? Again, you should remember 6 properties, that is 3 plus 3. First three, sine inverse of minus x is equals to minus sine inverse of x. Second one, tan inverse of minus x is equals to minus tan inverse of x. And then cosecant inverse of minus x is equals to minus cosecant inverse of x. That means for these three inverse trigonometric functions, sine comes outside. Whereas for other three inverse trigonometric functions, that is for cos inverse of minus x is equal to pi minus cos inverse of x. Then cot inverse of minus x is equal to pi minus cot inverse of x. And for secant inverse of minus x is equals to pi minus secant inverse of x. So these 6 are very useful in solving a trigonometric, that is inverse trigonometric problems. Okay. So next, sixth property we have sine inverse of x plus cos inverse of x is equal to pi by 2. Tan inverse of x plus cot inverse of x is equal to pi by 2. Then secant inverse of x plus cosecant inverse of x is equals to pi by 2. Okay. So we will prove one by one. So first one we have, so that is sine inverse of x plus cos inverse of x is equals to pi by 2. Pi by 2. Okay. So here put sine inverse of x is equals to theta. Therefore, what is x? X is equal to sine theta. X is equals to sine theta. So therefore, once again x is equal to, now we try to convert this into what? Cos. So we know to convert sine into cos. So you have to use what? 90 plus or minus theta. Therefore, I will write like this, that is cos of pi by 2 minus theta. Cos of pi by 2 minus theta. So we will check out this. So we know that cos of pi by 2. So that is, I already told you that 90 plus or minus theta ratio changes to its co-ratio. Therefore, cos of pi by 2 minus theta. So the ratio becomes what? Sin theta. Now we have to determine the sign of that. So cos of pi by 2 minus theta, pi by 2, that is comes in which quadrant? 90. So 90 comes in which quadrant? 90 minus comes in which quadrant? First quadrant. In first quadrant, all the ratios are positive. Therefore, becomes what? Positive. Okay. Now bring this cos to LHS. Therefore, that is cos inverse of x. Cos inverse of x is equal to pi by 2 minus theta. Okay. Bring this theta to LHS. Again, therefore, theta plus we have cos inverse of x is equal to pi by 2. But what is the value of theta? We have sin inverse x. That is sin inverse of x plus cos inverse of x is equals to pi by 2. Pi by 2. Okay. Hence, proved. Again, put sin inverse of x is equals to theta. Therefore, theta is equal to sin theta. Now try to convert this in terms of cos. Therefore, the sin theta is equals to what? Cos of pi by 2 minus theta. Again, bring the cos to LHS, it becomes cos inverse. Therefore, cos inverse of x is equal to pi by 2 minus theta. Again, bring the theta to LHS. Therefore, becomes plus theta plus cos inverse of x is equal to pi by 2. Substituting the value of theta, that is sin inverse of x plus cos inverse of x is equals to pi by 2. Pi by 2. So, example, if it is like this, that is sin inverse of 1 by 5 plus cos inverse of 1 by 5 then we can write answer as pi by 2, pi by 2. Okay, so it is in the form of sin inverse of x plus sin inverse of cos inverse of x is equal to pi by 2. So what is the value of x? That is 1 by 5. Therefore now this is equal to what? Pi by 2. Okay, next property we have, that is tan inverse. So tan inverse of x plus tan inverse cot inverse of x is equals to pi by 2. So tan inverse of x plus cot inverse of x is equal to pi by 2. Same method, that is put tan inverse of x is equals to theta. Therefore what is x? X is equal to tan theta. X is equals to tan theta. Again x is equals to, so we have cot of pi by 2 minus theta. Cot of pi by 2 minus theta. Again, therefore cot inverse of x is equals to pi by 2 minus theta. Bring the cot to LHS. Okay, therefore again bring the minus theta to LHS. That is theta plus cot inverse of x is equals to pi by 2. Again, therefore what is theta value? We have tan inverse x. Tan inverse of x is plus cot inverse of x is equals to pi by 2. Hence proved. Next we have that is secant inverse of x plus cosecant inverse of x is equals to pi by 2. Here same method, that is put secant inverse of x is equals to theta. What is x? X is equal to secant theta. X is equals to secant theta. Again x is equal to, that is cosecant of pi by 2 minus theta. Again that is again cosecant inverse of x is equals to pi by 2 minus theta. Again bring this theta to LHS. Therefore theta plus cosecant inverse of x is equals to pi by 2. Theta value, that is secant inverse x plus cosecant inverse x is equals to pi by 2. Pi by 2. Hence proof. Okay, so that is sin inverse of x plus cos inverse of x is equal to pi by 2. Next one, tan inverse of x plus cot inverse of x is equals to pi by 2. Then secant inverse of x plus cosecant inverse of x is equals to pi by 2. Next property we have tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y whole divided by 1 minus x into y when xy is less than 1. Next, tan inverse of x minus tan inverse of y is equals to tan inverse of x minus y whole divided by 1 plus x into y. So when x greater than or equals to 0 and y greater than or equals to 0. Then how to prove this? So you must remember these conditions also. Okay, the value of x, y must be less than 1. Okay, here plus 1, that is tan inverse of x plus so tan inverse of y is equals to tan inverse of x plus y whole divided by 1 minus x into y. Here let so tan inverse of x is equals to a. Therefore what is x? X is equals to tan a. X is equals to tan a. Similarly that is tan inverse of y. Tan inverse of y is equals to b. So what is y? Y is equals to tan b. Y is equals to tan b. Okay. So now that is tan of a plus b. Tan of a plus b. We have formula, that is tan of a plus b is equals to tan a plus tan b whole divided by 1 minus tan a into tan b. Tan b. Again that is equals to, now we have the value of tan a. What is tan A? That is x plus tan B. What is tan B value? We have y. Okay, whole divided by 1 minus tan A, x, tan B, y. That is x into y. X into y. Now again bring this tan to RHS. Okay, therefore that is equals to tan inverse. That is a plus b is equals to, see here we have tan of a plus b, tan of a plus b. Now bring this tan inverse to RHS, right? Therefore it becomes a tan inverse of same term, that is x plus y whole divided by 1 minus xy. But what is the value of a? We have here tan inverse of x. Therefore that is tan inverse of x plus what is the value of b? We have tan inverse of y. That is tan inverse of y is equals to, so that is tan inverse of x plus y whole divided by 1 minus xy, 1 minus xy. Okay, again put tan inverse of x is equals to a. Therefore x is equal to tan a. Similarly put tan inverse of y is equal to b. Therefore y is equal to tan b. Now we have the formula tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Just substituting the values of tan a and tan b. Therefore so we have here tan of a plus b is equal to x plus y divided by 1 minus xy. Now bring the tan to RHS. Therefore a plus b is equal to tan inverse of x plus y divided by 1 minus xy. What is the value of tan a? We have tan inverse of x. What is the b? Tan inverse of y. Therefore tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y divided by 1 minus xy. 1 minus. Next property we have tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y whole divided by 1 plus xy. To prove this, consider let that is tan inverse of x is equals to a. What is x? Therefore x is equals to tan a. X is equals to tan a. Similarly that is tan inverse of y is equals to b. Therefore y is equals to tan b. Tan b. So now we have that is tan of a minus b. Tan of a minus b is equals to formula. So tan of a minus b is equal to tan a minus tan b whole divided by 1 plus tan a into tan b. So that is tan a minus tan b whole divided by 1 plus tan a into tan b. Okay. So now substituting values of tan a and tan b. Again therefore that is tan of a minus b is equals to tan a value. We have x, that is x minus y divided by 1 plus x into y. So therefore bring the tan to RHS. Therefore that is a minus b is equals to tan inverse of x minus y whole divided by 1 plus x into y. X into y. Again what is the value of a? We have tan inverse of x. Therefore tan inverse of x plus tan inverse of y is equals to tan inverse of x minus y whole divided by 1 plus xy. 1 plus xy. Okay, you should remember this. Next we have tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y whole divided by 1 minus xy. So this condition is important. When x greater than 0, y greater than 0 and xy greater than 1. So earlier we have that is tan inverse of x plus tan inverse of y. Tan inverse of y is equals to tan inverse of x plus y whole divided by 1 minus x into y. When xy less than 1, right? So Here we have tan inverse of x plus tan inverse of y is equals to pi plus tan inverse of x plus y all divided by 1 minus xy when x comma y greater than 0 and xy greater than 0. We will see the proof later. Next we have second one, that is 2 tan inverse of x is equal to tan inverse of 2x divided by 1 minus x square. We will prove this. Okay. So put y is equal to x in, that is tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y all divided by 1 minus xy, 1 minus xy. Okay. So put y is equal to x in the equation, tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y. Now replacing y with x, therefore that implies that is tan inverse of x plus we have tan inverse of x itself only, tan inverse of x, again that is equals to tan inverse of x plus x, replacing y with x is equals to 1 minus x into x, that is x square. Okay. Again, so this is tan inverse of x plus tan inverse of x. We have 2 tan inverse x is equals to, so that is tan inverse of 2x all divided by 1 minus x square. Okay. So this is the answer. Again, put y is equal to x in the equation, tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y all divided by 1 minus xy. Therefore we have tan inverse of x plus tan inverse of x is equal to tan inverse of x plus tan inverse of x divided by 1 minus x into x, that is x square. Therefore tan inverse of x plus tan inverse of x, 2 tan inverse of x is equals to x plus x to x divided by 1 minus x square. Okay. So here you should remember this 4 properties. One is tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y whole divided by 1 minus xy. Next one we have tan inverse of x minus tan inverse of y is equals to tan inverse of x minus y whole divided by 1 plus xy. Next we have tan inverse of x plus tan inverse of y is equal to pi minus tan inverse of x plus y whole divided by 1 minus xy when x comma y greater than equal to greater than 0 and xy greater than 1. Next we have 2 tan inverse of x is equals to tan inverse of 2x divided by 1 minus x square. Okay. You should remember these properties. Okay. So dear students, just go through once in the home and try to practice at least once or twice. Okay. So remaining we will see in the next class. Thank you.